I'll give you a small introduction of, take this as a talk for beginners / intermediate level. I'll basically give you a small showcase of what Elixir gives you as a tool. But take in mind that everything is a tool, so you pick the best tool for your job. Don't pick it because hype. But I'm hyped about this language, so please check it out, and I'm trying to sell this language almost. Also, another side note, I did everything I shouldn't for a live talk, which is everything in my talk is code. So my slides are code, and there's a demo which is also code. So if anything goes wrong, you know why, because you're coders. So please be kind and make fun of me at the end of the talk. Also, a bit of time to set up. No? Shit. At the moment, it's just a blank screen, right? Again, perfect. Arrangement, mirror. Okay. Okay. So, welcome everyone. We're going to talk about Elixir, like I've mentioned, and we're using a test case which is the next big unicorn, which is an emoji board. So, who am I? I'm just Filipe Cabaço, developer at Volkswagen STC Lisbon. Those are my Twitter handles and GitHub. I would advise on this slide, the most important part is GitHub, because everything I'm doing here is actually committed there, so you can go there and do whatever, destroy it. And what is Elixir? Elixir is a newish language. V1, if I'm not mistaken, has now 4 years, I think. And it's a really simple language. It has a Ruby syntax, so it's not that difficult. It's really user-friendly. It basically compiles everything to Erlang. Erlang is where the magic actually happens. It's not in Elixir, it's at Erlang, which has a beautiful VM developed by Armstrong. The guy was a genius because they actually created something really interesting with this VM. And one of the main features is it uses the actor pattern and everything is a message. And the big takeaway from this talk is everything is a message, everything is communicated between processes, and you'll see why this is kind of an advantage. And why should you think Elixir is a good fit for you? It's functional, so it's really easy to do some special weird stuff with it, and it's really concurrent safe. So anything you do will actually be really solid. It's reliable. That's the main feature from the Beam VM, which is the Erlang VM, which is basically, it's really capable of just getting completely teared down. It actually has the capabilities to go up again. It's really resilient. It's concurrent. Like I've said, everything is message passing from one process to another and so on, and that gives automatic advantage of everything becomes concurrent out of the box. And the other advantage is it's actually scalable, connecting Erlang nodes, so connecting different Erlang VMs. It comes out of the box, it's one click, one password configuration, and that's it. It's really that easy. It's not complicated, and you can actually move really fast with this. For today, what we will do here. So I'm going to take you through the steps of how to create a small Elixir app, and how it actually structured, why do we do it this way, and so on. We'll connect it to Kotlin. That's another feature that Erlang brings, and usually people don't talk about much, but I think it's actually a really interesting feature that can be useful for some. We'll send a package of information for a web client, in this case, this presentation. We'll actually take a picture and replace every single pixel with that emoji. And at the end, if everything goes well, and I have time, I'll actually show why having concurrent primitives inside the language is actually really good to parallelize some jobs. So I'll just do a small switch and try to show you why this is actually a good thing. So now comes the part that is really difficult, which is booting up a project, which is this. You basically do this, it creates a project. The Elixir language includes this mix command. The mix command actually does a lot of it. It does dependency management, it does packaging, it does a lot of things in just one tool, and it's really solid and yeah, quite easy to use. This will be the looks of our thing, where we have a server, a worker, and a client. So now we'll just focus on the emoji supervisor. Now do we create the emoji supervisor? Erlang and Elixir, since they actually have a long history, they already bring a lot of recipes with them. It's basically, they have some behaviors that you can apply, and that will basically translate into some way of that process to work. So to do it, you just do, I bet the code is really small. No, not that bad. So to do it, you'll basically say, use supervisor, that will do some magic underneath, that will actually implement the behavior of a supervisor into this module. Then you need to give it a start link, which is basically, hey, wake up. Basically goes, please start as a supervisor. And then you say, okay, my initializer is, I'll give it a list of children, and then you need to supervise these children. And this is how you start to create your tree. The tree can become a mess, but I'll actually go into that, which is, what the hell is a supervisor? Why is this interesting? Well, this is the official definition. Blah, 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 blah. This is my definition. Supervisors are helicopter bosses. They basically know what you're doing, if you're alive and you're not alive, and so on. Supervisors can supervise other supervisors. It's basically the boss has a boss, which has a boss. So this actually starts to create a tree of, I'm checking that guy is checking another guy. And this tree is actually how you control what lives and dies and how they actually restart and so on. So imagine that you have one supervisor that the only thing it does is, I want to consume something from RabbitMQ. Okay, I'll supervise a consumer that does that. For some reason, RabbitMQ blows up, the consumer says, oh shit, I'm dying, done. The consumer dies, the boss will go, okay, get back to life. RabbitMQ is already good, we waited for a bit, now you can come up. So it's really a way to bring resilience to, you don't need, when there's an alarm, you'll basically go, okay, something will wake it up after a while. And yeah, that's basically it. It's the world's best boss that knows how you are and actually reanimates you if needed. But how do you define that reanimator? What the kind of policies do you have? Well, you basically just need to define a strategy. There's more to it, but out of the box, you basically have this idea of one-for-one where the guy dies and the supervisor goes, quick, give me the defibrillator, let's just bring him back up. You have one-for-all, which is one guy dies and the father goes, no, kill everyone, and then bring them back all to life. So it's a bit, well, genocidal, but that's some use cases this is actually useful. Imagine that you want to stop a pipeline of consumers. One of the consumers died, that might create out-of-order problems, so kill everything before actually having this problem. Then you have another one, which is rest for one. If 2.2 dies, for example, worker 2.2, 2.3 from there on will actually die. The other ones on top won't. And this, they basically created this to help out with the mentality they really have, which is let it crash. They really like this resiliency, they have these strategies, they have everything because they don't want to handle every single failure. A good analogy for that is, you have cars. When a car crashes, it's not an expected behavior, but at least the car is prepared for that behavior. The Erlang VM follows a bit that idea. They're not prepared for a crash, but when it happens, they'll actually bring it up. And it's much better for the developer, as a developer, to just code your thing, and if it blows up, Just tell him, okay, when you wake up, this is what you need to do, and this is your job. So you don't need to handle a lot of the business cases that are really annoying. Just reanimate it. Accept failure and move on. So with all that talk, we actually need something to supervise. We already talked about the bosses, now we need the workers. So again, following our small slide of architecture, we'll use another behavior called the gen server. This is basically the recipe for you are a worker. And it's focused on receiving messages and handling them. Because since everything is a message, you need to receive messages in some way. To do it, you'll basically do this. You just use gen server, start link. Start link is the recipe for him to go, yeah, I am this guy, I'm going to start up, my name, it's myself. That's basically that underscore underscore module. The only thing it's saying is, give it my name, it's a self. And then it runs that init command where you would, for example, imagine that you want to pull something from the database. You run that code there, it's locked, it basically locks the thread until it's done. There's ways to go around it, but that's the place to do it. It gets everything ready, it says, okay, I'm ready, gives a state for that process, and from there on forward, you have a kid in your neighborhood having some fun. What do we have available out of the box with Gen Server? We have 3 callbacks. I'll show you better with code afterwards, but we have handle call, where basically it's a synchronous thing. If you send a message, the person that sent the message will wait for a response, and when it gets a response, it goes, cool. A cast, which is the async version, where you send a message and, okay, I don't care about this guy anymore. The guy knows he needs to do some job, done. And the info is for everything else that it's not inside Gen Server, because since everything inside Erlang is a message from another guy, you need a way to handle those special cases where something is not compliant to Gen Server. So you need another way to handle it. And that's the handle info. And it's also async, that's why there's a conflict there, but it's legacy reasons, but also useful for other stuff. This is the callback. It's not magic. It's basically handle call gives you that small piece of code where you do some pattern matching. We'll go into in the next slide a bit more in detail. But you give it, okay, when you receive this message format, you do this job. In this specific scenario, what we're doing is I read a file, I connect to a worker, which is basically go connect to Kotlin. When you connect to Kotlin, send the contents of that image to that mailbox, and my work here is done. As a process, I don't need to do anything else. On the upload side, which is actually calling that worker, what we have here is basically an upload endpoint. It's nothing magical. We do some pattern matching. Like I've said, this is the magic part. We basically can extract information directly. What this means is if any other thing tries to call this upload method without that specific format, it will fail. And when it fails, some supervisor will bring that up. I don't care about it. I don't need any ifs, else, whatever. The only format I accept is I want to receive inside my body a parameter called file, which has that specific path. That's it. I don't care about, oh, what if someone sends, instead of sending path, sends something else. No, I don't care. Let it fail. Let the client actually comply to my contract, because I'm not here to take care of others. I'm here to take care of my work. On this server, what we do is, when an upload happens, we send a message to the worker saying, look, I'm sending you, for this worker, I'm sending the message saying, look, this is the instruction I want you to do. This is the path that you're going to affect. And by doing that, it basically goes through this code, says, okay, I'm done. Reply, okay. And this guy receives okay? And it sends a response, yeah, everything went fine. I don't need to do anything else. And then we actually need to add it to the supervisor. From this point forward, this emoji board supervisor will be the father of this guy. And if this emoji board process dies, he'll be there to wake him up and bring him back up. So he's a really nice guy. Now we'll go to another step, which is connect to Kotlin. This is not a normal use case, but I wanted to bring some attention because this is a feature that people forget about Erlang, which is really, really good. Erlang it's also more than just a technology, it's also a bunch of protocols. There are a bunch of contracts. And inside those contracts actually enable you to speak with other languages. Because if the language can talk Erlang, it basically will be able to talk with the Erlang VM out of the box. And Erlang actually provides one thing that already does this. They basically give you the code away. It's a really simple library to use in Java. And I've used Kotlin because it's much better to program. And again, since you comply to the protocol, it means that you also comply to the idea that everything is a message. So it doesn't matter what kind of message you're sending, everything is a message, it doesn't matter the language, it just matters that you're actually sending messages between each other. And this is a good way to leverage a lack of features or lack of things you've missed from other languages. I'll give you an example. I actually had a system in production where we had to use Cassandra. And the first part of the journey was really good with Elixir. The second part of the journey, which is actually storing and doing some extra stuff with Cassandra, would have been better with Java. I've developed something using Cassandra lib in Elixir, and it was a mess. It was not well supported, it was still too young, it was a mess. It would be much better to just have, okay, I'll have a Java connector that handles that part. It's acceptable, and some people actually do it. There's a database called React that offers an Elasticsearch alternative, and basically what they do is they have an Erlang VM and a JVM running by the side doing the weird part of Solar, something like that. So it's a good feature that a lot of people forget, but it's there. How do I connect different machines? Because technically that's what we're doing here. So first of all, Erlang offers another tool when we install it, which is the EPMD. And this tool, the only thing it does is you connect to it, and the guy goes, okay, I'm ready to do handshakes. Another guy connects it, cool. Whenever you guys want to talk, just ping me and I'll connect you guys. He's basically the, I don't know, public relationship guy in this. You set a cookie, so at least you have that secret handshake, but it's not encrypting anything. It's basically, do I know you? Yeah, do our secret handshake. The guy does the secret handshake, cool. You're a cool guy, let's actually talk. Now we actually want to connect to the worker. Well, the worker has a name. We basically do node connect. It says, yeah, I know that guy. Basically, at this point, it talks to EPMD. It tells him, yeah, I know this guy, cool. We ping him to make sure the guy is there. Okay, he responded Pong, that's fine. Then I'm connected. And I also need to handle generic messages in this case, because the guy on the other side, being another language, doesn't comply to the gen server behavior. So I need to be ready to receive kind of generic messages. On the Kotlin side, we do, again, basically an OTP node. The OTP node, what it means is I'm creating a process, almost. I'm creating my own fake Erlang VM somewhere so I can identify with it. I set a cookie, again, my secret handshake. I create a mailbox. That mailbox is something that lives inside every process in Erlang. In this case, we need to create one for Java, and it's an object. And then we actually start receiving message. How do I receive messages? Well, you just receive them. Mailbox.receive. It basically does a stop the world, and waits for a message. When it receives the message, it goes forward. So what we have here is just a recursive call. I wait on the receive, I receive a message, I parse that message and use it how I need it. And that usage, it's basically here. This is the ugly part about it. You need to basically take it out of the structure that the library has. So there's some conversion here, but it's not that difficult. Then our Kotlin guy will actually go, okay, cool, what do you want me to do? Well, I want you to, first of all, keep the sender, because I want to send him back a response later. Please give me the binary file, which is the image. It gets all the binary input, creates a file, and does some processing, which is this part. And in this scenario, it basically goes through each pixel, checks out the RGB values, and parses an alpha value for it. And after that, it basically goes, okay, now that I've done my work, send it outside. I don't care. Send it to my sender. I'm done. And on our side, that handle info that needed to handle generic messages, we basically go, cool. I received some content from somewhere, and with that content, I actually want to send it to the WebSocket. So again, we need another worker for this. We need a guy that is specialized on sending something to a socket. So that's what we're going to do. This is, I'm using Cowboy, which is a web server thing. It's not relevant for here. The relevant part for this is here, which is whenever a guy connects. I'm sending to this guy, again, everything is messages. I'm sending to that sender that, look, someone has joined, and it has this specific request, which includes some WebSocket features like, I don't know, a secret key, a unique identifier, and so on. It has some information that we'll need later. The other thing I do is, okay, this guy actually left the channel, so I'll send to that specialized guy that the only thing he does is send stuff to sockets. Be aware, someone has left. So the guy will need to act upon this message. But there's a lot of, you need to trust the other guy to do the job. You send a message to him, done. That guy, I know that guy is the specialist, but you need to trust him, and you'll send a message and everything will be fine. So that specialist is, again, another worker, so gen server behavior, and receives one call saying someone has, it acts upon a call of, yeah, someone has joined, yeah, someone has left, and that's it. This is just, again, pattern matching to extract information, which is a really useful way of extracting information. And it goes, again, to the idea of, if I ever receive something I'm not expecting, let it blow up. I don't care about their error. That's fine. I don't care. It basically says I'm not able to pattern match against that, and it doesn't care. So what we do here is, this guy joins. I check if the guy exists already in my state, and add it to that. That's just the only thing I do. Because another important thing about these workers is that each one actually has its own state. As you guys know, state management is probably one of the hardest things anyone has to do. And in this scenario, it's actually quite easy, in my opinion. It makes a lot of stuff easy because when you manipulate state of a process, everything is by order. When he receives a message, you basically say, okay, the new state for this guy is this value. And the guy goes, okay, I've done my job. I've said okay. I was able to join to this. And then I say, your new state is this. The next message won't have any kind of conflicts or problems or deadlocks or whatever. It basically goes, okay, I received a new message. What do I need to do? You just need to take out the guy from the list. Cool, I'll take out the guy from the list. Oh, by the way, there's a new state. And since everything is by order, it doesn't clash and it just flows quite easily. Finally, this guy actually needs to do some job, which is you receive the message, and this guy needs to send something. Otherwise, he's not doing his job. At the moment, he's just collecting WebSockets and not doing anything with them. So what we do here, upon that state, so when I receive a message, processed content, upon the state of that process at that moment, I send a message to clean my client, and I send it all my content. And then I say, okay, since I'm async, I don't care. I'm not giving any response. The only thing I'm doing is I'm not replying to anyone. But I'm updating my state, just to be sure, if needed. So the send content, the only thing it does is simply grab a PID. The PID is a unique identifier for each process. In this case, each WebSocket has its own PID, which means that I'm capable of sending a message to that PID saying, you need to send this through the WebSocket. Again, everything is messages. So you kind of look at it and say, you just need to understand the message passing and what messages you need to comply to and the contracts they have, but everything becomes messages. So it becomes complicated when you develop a lot, but it's easy to start and to actually solve a lot of complex cases from the start. And then, yeah, I just do send to that specific guy a giant JSON with a lot of pixels. Then we also add this guy to our supervisor. And this supervisor goes, no, now I have 2 kids, cool. Whenever one of them dies, I'll bring them back if required. And the other thing I do is just put here when this machine starts up, try to connect to EPDM and try to connect to, and tell someone that I'm alive somewhere. And that ends up here. So, again, everything is live, so everything messes up. I hope that, yeah. So what happened in this case, it's using my webcam, so it's not the idea. I want to take a picture of you, I'm sorry. I need to save this one. But really the idea is, at this point, we had, again, live demos, useful. We had a file sent to Elixir. Elixir basically parsed the binaries out of it. From those binaries, it sent to Kotlin. Kotlin got them back after doing some calculations. And basically, Elixir said, OK, now send this back to our WebSocket. And I really need to save this. I'm sorry. You guys will stay in my Twitter or something. And this was done not that slowly, because it's a lot of pixels. It's a lot of information being handled. And it wasn't that difficult to program. If you go look at the code, it's not that complicated. And another thing, let me actually check if OK, I have enough time. The other thing I want to show you guys is this. I'll actually kill the machine, because, just to be sure. What I did is, instead of going one by one, instead of saying you're just sending one message, the only thing I do is, guys, why the hell are we doing this? We have built-in concurrency in our Lang VM. Let's actually use it. And Elixir created a lot of helpful syntax to actually achieve it quite easily. This task.async basically creates a side process that is supervised by this guy that just does whatever you want. And then when it finishes, it sends a message back to this guy. Meaning that, imagine that I'm doing, I don't know, data processing of some kind. I receive a lot of information from RabbitMQ again, and I say to them, cool, now I want to separate this job into a bunch of tasks. I want to leverage as most CPU as I can. Okay, then do it. I'll task async it. When it comes back, I receive a message. And when I receive that message, I'll act upon it and save it in my state. So it's a good way to do kind of reducers. And it's not that, again, to achieve it, since it's a concurrent language, it's not that difficult. It's one line of code where I go, yeah, you remember the job you were doing? Now do it inside the task that will create a process and so on. So, again, it's one of those languages that I fell in love with. It's quite easy to use, and my call out is try it for a small project and check it out and have fun with it. It's one of those languages when you start to see your code flowing, you feel really a big happy feeling and fuzzy feeling inside of you, because you're basically handling really complex stuff with not a lot of syntax in a really easy way. Also a call out to the Elixir meetup. There's an Elixir meetup in Portugal, which is organized every month, if I'm not mistaken, and it's a really welcoming community. That's another call out I want to do. And yeah, I hope you guys enjoyed it. Sorry for some live demo issues, and sorry for the amount of code. I know it's kind of overwhelming, but yeah, thank you. Any questions? Now it's time to bash, if you want. Okay, that's good. Then we have time for lunch.